This video is about interpreting graphs, plotting points on the coordinate plane and identifying their quadrant, and working with multiple representations of a given situation. So remember that a coordinate plane has 4 quadrants. Each quadrant represents a different type of coordinate that's distinct to its quadrants. Quadrants are numbered counterclockwise. So we have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. In quadrant 1, our x and our y coordinate are going to be positive. In quadrant 2, our x coordinate will be negative and our y coordinate will still be positive because we're above the x-axis. In quadrant 3, both the x and y coordinate will be negative, and in quadrant 4, the x will be positive, but the y will be negative. So before we go back and look at roses are red and flower power, we need to make sure we know how to plot points on a graph. So remember that the vertical axis is your y-axis, and the horizontal is your x-axis. Points are always written in the form x comma y. The x-coordinate shows us how far to the right or to the left we go from 0, 0, which is known as the x-coordinate. Or, sorry, 0, 0, which is known as the origin. The y-coordinate tells us how far we go up or down from 0, 0. So first we're going to work on, there's points on the graph and we need to identify what their point is. So A is right here, and for A it lines up with 6 on the x-axis and 2 on the y-axis, so our point would be 6, 2, and A is in the first quadrant. For point B is up here at the top. The x-coordinate is 2, the y-coordinate is 9, so our point is 2, 9, and again this is in the first quadrant because both points are positive. C is over here in the second quadrant, and for C we line up with negative 7 and 3, so the coordinate would be negative 7, 3. D is on the y-axis, so when it's on the y-axis, the x-coordinate is going to be 0, and the y-coordinate will be 1. So we have the point 0, 1, and the location here is the y-axis. E, we go negative 6, negative 5. So E is at negative 6, negative 5, and that is the third quadrant. And our last point, F, lines up with 8 on the x and negative 2 on the y, and that is in the fourth quadrant. So plot the points, the following points on the coordinate plane above. So G is at negative 2, negative 6. So we go to negative 2 on the x-axis, negative 6 on the y-axis, and this is our point G. H is at the point 0, 9. So starting at the origin, we don't have to go left or right because it's 0. And it's 9, so we're going to go up to 9 on the y-axis. This is our point H. I has the coordinate negative 5, 0. So we're going to go to negative 5 on the x-axis, and I don't go up or down at all. So this is I. And J has the coordinate 4, negative 9, which is in the fourth quadrant. So let's look at some graphs and compare some information. So Shauna Motors is considering building a manufacturing motor vehicle plant in the town of Benton. Mayor McDennis and the city council are trying to convince Shea Motors to build the plant and bring jobs to the town. We Breathe the Clean Air Environment Group is trying to stop the plant from being built to cut down on air pollution. To determine the true facts, Shauna Motors also has an independent investigator to research. So we have our graph A, B, and C. And notice in all the graphs, we have our years on the x-axis and we have our population on the y-axis. So the graphs look a little bit different. So how are the graphs different? So when we're looking at the graphs are different for a few reasons. The lines are located higher or lower from graph to graph. Okay, we can also notice that while the years are going the same, if we look at the population numbers, the numbers on the y-axis are all going up by different numbers. So we can say numbers on the y-axis are different. How are these three graphs the same? So if I look at the graphs and I start to look closer at my data points, notice that the data points are the same. So in this 2000, we have a population of 10. In 2002, we have a population of 10. In 2002, we have a population of 10. So the data points are still remaining the same. So there's two things that are the same. The labels on the axis are the same because we have years and population, and the data points are the same. So if we had to guess, which group do we think would represent it? So looking at this, remember that the city council and the mayor were trying to convince them that there's a big population and a need for jobs. So we would say that the city council is graph B because they're trying to show the biggest population. The environmental group is trying to show that jobs would not help here and that it's going to just hurt the population. So if we look at C, we see a really slow increase. So C is probably the environmental group showing there's not a big population here. You want to stay away from here. So this is graph C, which means that the researcher would be graph A because graph A looked kind of like a neutral graph. So using the information in graph A, B, answer the following questions. So the graphs look different. Do they represent the same data? If so, how do you know? So while the graphs look different, are they representing the same data? Yes, because look at our labels. The labels on the axes are the same. So do they represent the data, the same data? Yes, because the axes have the same labels. And let's look at the data points. So in 2005, we're starting here around somewhere between 40 and 50, probably 44, 45, and the same thing in the other graph. So notice that the data points are the same. So we can say the axes are the same and the data points are the same. Explain or give an example of a person who might want to use graph A. Well, graph A looks like the tuition isn't really going up that fast. So somebody that might want to use that data could be the College Board. They want to show, oh, the money's not going up that high. You know, our school is still kind of cheap. We're not really raising the money a lot. If we look at the horizontal axis, how much does each line represent? So the horizontal axis in graph 1 is over here. And notice that we're going up by 1 year each time. So each line represents 1 year. If we look at the horizontal axis on graph B, the same thing's happening. The horizontal axis is still representing 1 year. What is the major difference between the way the annual tuition axis is set up from graph A to graph B? So if we look at the annual tuition in graph A, notice that it's going up by 10,000s, while in graph B it's only going up by 1,000. So we could say that graph A is increasing by 10,000s, and graph B is increasing by thousands. When does the tuition go up the most? So if we look at our graph and look at the line rising, it's kind of easy to see from B, we see this little graph that's going the highest, but in B we can really see that it's jumping from here to here. So the year that it's changing is 2008 to 2009. We see the biggest jump in tuition.